It is with great sadness that we begin our sixth and final help video over 8-20 Test Premiere Part 2, the written part. When we last left off, we had realized that the net ionic equation for the reaction of aqueous zinc fluoride and aqueous ammonium sulfide, the net ionic reaction is just that zinc 2 plus bumps into S2 minus. That large charge that each of those have, they pull together, they hold together strong, and water cannot pull them apart. They precipitate out of solution. In question 34, they want us to draw this. Now, when we draw this, they really want us to draw everything that is floating around in solution. So the one they want us to draw is right up here. They don't want us to draw the net ionic equation. They want us to show everything that is floating in solution. So what is floating in solution? Well, for every one, we have a zinc 2 plus floating around for every 2 F minuses and every 2 ammonium ions and every 1 sulfide ion. So we need to draw a zinc 2 plus. This side is what is floating around before it reacts. We have a zinc 2 plus. What else do we have floating around in solution? We have 2 F minuses floating around in solution. So there's one of our F minuses, there's our other F minus. Also floating around in solution, we have S2 minus. We have an S2 minus floating around in solution. There it is, the S2 minus. Now, what happens in this chemical reaction? What happens is, invariably, these ions are free to float around throughout the entire water. When you have liquid water, the water molecules are continually moving and pulling along with them as they move the ions that are attracted to them. So it is certain that these zinc ions, are going to bump into S2 minuses that are nearby. And these 2 plus 2 minuses charges are strong. They will pull together, and water cannot separate them. It's like water's the chaperone at the dance, trying to keep all these players apart. And when these two get near each other, they bump in, and water cannot keep them separated anymore, and they'll precipitate out of solution. The NH4 pluses and the F minuses, they don't bump into each other and hold on. Water can keep them pulled apart like chaperones at a dance, can keep them from dancing too close. They will be free to float around. So the NH4 pluses continue floating around. The F minuses continue floating around. It's just the zinc sulfides that precipitate out of solution. So what happened? Well, in the reactions, the NH4 pluses started out floating around. After the reaction took place, they are still floating around. Nothing at all happened to the ammonium ions. Likewise, we have fluoride ions floating around before and after, and we have fluoride ions there floating around before and after. Nothing happened to them. The ions where nothing happened to them, no changes. They just watched the zincs apart, join together, leave. What do we call this? Spectator ions. So there are 2 spectator ions that need to be labeled. The ammonium ions and the fluoride ions are spectators. The next question, and our final question in this packet. Do double displacement reactions, can they also be categorized as oxidation reduction reactions or redox reactions? Why or why not? Well, we recall oxidation reduction reactions, redox reactions, involve oxidation numbers changing in the reaction. Oxidation numbers changing in the reaction. Oxidation, the process of oxidation, if you remember, that was oil. Reduction, we learned, was easy to remember when we think of rig, oil rig. So we have oxidation. Oxidation happens when something loses control of electrons, or actually loses electrons. Reduction involves a gain in electrons or gaining control of electrons. It involves electrons. When we look up here, there is no changes in electrons. On this reaction right here, in the single displacement reaction drawing that we did, there were changes in electrons. Aluminum was forcing copper to get electrons. So copper went from 2 plus back to neutral. It was reduced. Its number went from 2 plus, oxidation number plus 2, down to 0, oxidation number of 0. Reduction is gain, Rig. Copper gained electrons from the aluminum. The aluminum started out with 3 electrons and lost those 3 as it became 3 plus. Oxygen went from 0 up to 3 plus. Aluminum went from neutral up to 3 plus. It was oxidized. Oxidized is loss of electrons or loss of control of electrons. Single displacement is oxidation reduction. When we look at this double displacement reaction, nobody's charges changed. Nobody gained or lost control of electrons. All that happened is zinc was 2 plus. It grabbed onto the sulfur, which is 2 minus. That big plus 2 plus minus 2, or big 2 plus 2 minus charge, they pulled together and could no longer be pulled apart. Water could not keep them separated. So double displacement involves no changes in charges. Everything that goes into the reaction has the same charge. The zincs over here are still 2 plus on the product side. The sulfides are still 2 minus. They just pull together and it's neutral overall because the 2 plus is balanced out by the 2 minus. So the ionic charges do not change. If the ionic charges do not change, the oxidation numbers do not change because the oxidation number is always the same as the ionic charge, just written differently. When you remember, ionic charges are written number followed by charge. Oxidation numbers are written by charge followed by number. That is why double displacement reactions are often called net ionic exchange. They're just exchanging what ion they're with. They're exchanging partners. Nothing else is really happening here. So double displacement is not a type of oxidation reduction reaction. This brings to a close our sixth and final help video. Over the 35 questions contained in 8-20 Test Premier Part 2, the written part. If these help videos did not clear up any confusion that you may be having, please email me. We can make additional help videos. We can set up a meet where we go over anything that is confusing to you, or if you would just prefer, we can email back and forth until you understand and are confident in this material. Thank you so much. Unit 8 is now coming to a rapid close, and we will begin our final unit of this 9 weeks. Unit 9 will be the last unit that we can get through during this e-learning time, and it is an extremely important unit. So we look forward to starting Unit 9 in the very short future. Have a great day.